Hi, a good day. I have here today two Folktek Alters, a 1 and a 2, and they both don't work anymore. A guy from somewhere in Europe said this to me, said he smelled some whatever it was, and flickering lights, they don't work anymore, and that's how I got them. I already opened one up. I didn't have any Folkteks here before, so I was really curious to see how these look and how they work. And I found out that they're using, well, it's actually quite a complex one. This is the spin FVP, whatever DSP chip this is. It's used a lot. Got all the effects in there, and you can program it yourself with algorithms that you make yourself. It's not easy, but you can do it. And Folktek made two different versions of the firmware on these chips, and this guy has them both. I've been on the lookout for this module for a while personally, so I'm really interested. And I found out that the power supply is actually quite different from what I see a lot of times in the Eurorack. It uses a MC34063, which is a 3 to 40 volt DC to DC converter. And you can set it to generate specific voltages, I believe. I believe it's an adjustable voltage regulator. I just haven't seen it before like this. And, well, I'm not sure if you can tell, but this one is actually cracked. This is the IC with all the power buffering next to it. And you can clearly see, well, at least I can, a crack. So this probably smoked, and, well, I ordered some replacements, and before I swap them out, turn on the power, I just want to do some measurements and make sure we don't have any dead shorts in there or what else may be wrong. So first, let's do this one. This is the front, and this is the power connector. Set it to resistance. Ohm on the plus rail and open circuit on the minus rail. So this is the same the other way around. So let's swap it out for another one, because, well, this one is clearly broken. It's actually, well, it's quite tight up there with all the caps and such. I don't think I'll be able to get this one in there. I can take off this jumper. There's a lot of jumpers and headers on here where you can, I don't know, dry wet, outputs, inputs, pedals, okay. interesting. There we go. Let's straighten those legs a little bit. There's the click. Now if you measure between ground and plus 12, well, 50k rising, 500k, so that's the cap charging. I think, and I think the minus rail, yeah, it's still open, and I think that's because it's not even used. It's a digital module, and it will probably do the rail or the work from the 12-volt rail. I did notice that this Atmega 328p was not seated very well. Do I dare to power it at this point? Let me check one more thing. Yeah, okay. So I'll get this out. And let me prepare my bench power supply to create the power rails, and I'll be right back. So I have it hooked up, and it's not turned on yet, is it? No. So it should probably draw only power from the plus rail, but I am going to limit the current to 80 milliamps for starters. You can always raise it if it doesn't work. 80 milliamps. Yes. So let's turn it on. No, that's not enough. 100 milliamps. No, even that's not enough. Let's make it 150 milliamps. Still not enough. 200 milliamps. Still not enough. How much does this draw? 300 milliamps. Yeah, it did draw a power up. It did draw a little bit over 300 milliamps. But as soon as it was running, it dropped down to, let's check it again. 150 milliamps. So now what we want to know, does it work? Does it run hot? No, it does not. I can see the LEDs light up. But I'm not sure what I'm expecting what it should do. So let's hook up some audio and see what we can get. So yeah, if you ask me, that's the same old distorted spin view or whatever this DSP is called. I consider this one fixed. Let's try the other one. I actually don't need to remove the front panel to replace this power chip. But before I do that, I am going to make sure that I get the same readings. Because he said they both stopped working. But this is measuring exactly the same as the one that I just repaired. A lot of resistance on the positive power rail. And the same here. Which makes me wonder, is this one broken or is it not? Power is off. Let's turn it on. No, there's a short in here. There's definitely a short in here. Immediately raised to 400 milliamps. But this doesn't measure like a short. As soon as I run power, bam, 400 milliamps. I don't like that. Is it the power IC? Let's give it a try. Yeah, let's start with that. That's easy enough. Can yeah, that's for later, to see if this one actually is broken or not. Because if we compare the two, we can clearly see that one is visually broken and the other is not. So here's a new one. Power is off. And it seems to be, yep, 150 milliamps. Let's give it some audio. I think they both are fixed. Now, what can we learn from this? Because we have two broken regulators, but if I recall correctly, I remember having a look at the design. Power comes in here and I see here a diode, which I think is just the diode is just forward biased on the positive power rail, which means that if you were to reverse it, power doesn't come through. So it should be protected against reverse polarity. The 12 volt is, or the minus 12, sorry, doesn't seem to be connected to anything at all. Or is it? Because, yeah, there are op amps here. Does it just run off the positive rail, like bias the voltage rails to the op amps? Yeah, it could be. Why would you do that? It's not a guitar pedal, is it? It probably also runs on lower voltages as well, then don't you think? Okay, so I see reverse polarity protection with the diode, but if we have a look at so here it is. This is the DC-DC converter that got blown up. It's operating from 3 to 40 volts. So yeah, that's quite robust. Active current limiting, well, didn't work on this one. Monolithic control circuit, which is the main function for DC-DC voltage converting. Internal temperature, blah 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 blah. There even is a timing capacitor. How would you connect a thing like this? Okay. What can we tell from just measuring continue or like short pins? And we have a collector to emitter on 1 and 2. Let's try that again. Well, that's the 400 ohms that we measured earlier. And on this one, yeah, on this one there's much more. So the transistor inside this one seems to be alright. From collector to ground. Emitter to ground. And then power is coming in on pin 6. Oh, why would one use a thing like this? No short to ground from the power rails. But this one, sorry. No, not even this one. So what exactly went wrong with these, I'm not entirely sure. Because they seem robust enough to handle some 12-volt reverse current. Replacing them did fix it. But how would a thing like this break? Well, the guy who sent it to me told me that he was... Well, it very often happens that when people change stuff around from rack to rack, then suddenly it stops working. And they're pretty much always confident that they didn't reverse power. Well, this one is boxed, so that would be actually quite difficult to turn it around, but a lot of bus boards from Doepfer don't, so yeah, and if you turn it the wrong way around on the bus board, yeah, it can depend. a lot of theory and nothing useful. Alright, to do the final test, before I completely wrap it up, because you don't want to have something still be broken when it arrives by mail. So I do a quick rundown of all the functionalities, inputs and outputs, and see if we get signal on everything. And while I was putting this back together, I also noticed that there's even a fuse on here, and that made me think about how some linear voltage regulators can work. That it's set for a certain voltage at the output, and the moment you short this to like the input voltage or anything higher than what it's supplying, then you have the possibility that it breaks down. And sometimes they put a diode back to the input power, so whenever that happens, the remaining power just gets pushed back to the input pin and not trying to get pushed back through the regulator. But this is actually the only thing I can think of that happened. While, yeah, maybe the 5-volt rail or whatever, yeah, it's probably 5-volt, yeah. Oh, I see here. There's a lot of jumpers to configure. I see -12, ground, 3.3 and 5 volts. So there's a lot of stuff going on power-wise. And it just looks like it shorted somehow. Let's put output to create a uh, 5-volt peak-to-peak sine. So I have a sine coming from here as a control voltage. Let's give it some power again. And enable us to listen to the output. Turn on the power. There's the noise. So we have 2 parameters, but 4 CV inputs. Ah, okay, so we have one. Let's. This one is working. The mix. Works. Yeah, it's working. Power all looks normal. It's not getting hot to the touch. So this one I consider a fix for real. And now for this one, power is off. Oh, actually, yeah. Oh. All is fine. Inputs, outputs work. Let's wrap this up and say goodbye. Oh man, I love this one, the number 2. Jeez. Well, that's it. Thanks for watching and see you next time.